Jai Hind. My name is Vikash. I'm an assistant professor in computer science and engineering department. The topic that today we are going to discuss is virtualization in the cloud computing. These are the topics that will be discussed in this presentation. Introduction of virtualizations, virtualization architecture, what is hypervisor, and types of virtualizations will be discussed in this. So virtualization is there. Generally, if we say, as per the Wikipedia, in the computing, virtualization is the act of creating in a virtual version of something that meeting at the same abstract level, including your virtual computer, hardware, platform, storage devices, and computer network resources are there. So it means in virtualizations has the ability to run the multiple systems on a single systems and share the resources such as your hardwares like your hard disk, your RAM, your network interface cards, and etc. are there. So generally virtualizations plays in a pivotal role in cloud computing. Why? Because in cloud computing, we use the concepts of the virtualization in order to provide better resources to the customers or the users, so that they can perform the task by using those resources are there. So in foundations, if we say virtualization foundational technology in cloud computing that allow for creating a virtual machine from a single physical machines are there. So if we have a single machines, we can create multiple virtual machines depending upon the capacity of that physical machines are there. And these virtual machines will act as an independent, where they have their operating systems, resources such as CPU, memory, storage, and networks are there. They can compute whatever the task is being given to them, or the user use those virtual machines and try to execute their programs or applications are there. Here, these virtual machines are not aware of the other virtual machines, or you can say they are not aware that they are being virtualized. A manner is there. So this virtualization basically helps allow the multiple users to share their physical machines and maximize these utilizations and improve their efficiencies are there. So the major questions arises why virtualization is being needed and why it is being currently in trends are there. First thing is, if we say we have a multi-programming environment where we share the different processes are there. We have one single process systems and the CPU is there, and different processes are being shared among the multi programs are there, or you can multi applications are there. But in the case of virtualizations, we can create an independent machines within that hardware, so that user can use it, and they have the independently work on that particular machines are there. So in virtualization, we can create multiples virtual machines on the provided systems, or you can say systems or hardwares are there, where the resources of the physical machines are being virtualizedly created, so that those virtual machines can able to provide the same kind of efficiency and throughputs are there. This is the representations where we have the this is the your standalone applications are there. Sorry. Okay, so in this we have the let's suppose this is a standalone systems are there, in which we have a CPU, memory, network interface card, disk are there, and they have the operating system and their applications are there. In this physical machines, only one systems are being running, and if we during the executions we know in that at certain types of that not a maximum utilizations cannot be done. So in order to utilize the maximum, we can create an virtual machines just like they where we have an architect, we have a virtual machines layers are there, in which virtual machines that is called VMM are there, that is virtual machines management are there, where this CPU, memory, network interface disk are being created, virtualized there, and we have in this particular machine, we have two virtual machines are being created. So in order to maximize the throughput or maximize the efficiency is there. So virtual machine is generally is an applications or a software is there which emulate the physical devices and work like those physical devices are there, so that the different users can share the resources and they work on those virtual machines are there. And these, if let's suppose these two virtual machines are there, there are two users are working on those virtual machines. In that case, this user one will not interfere with the user two virtual machines are there. Okay, so this is the where we have a difference between the physical and virtual machines are there. This is a general architecture here is there. This is a hardware on which we have this hypervisor is there. Then we have a different guest operating systems can be installed are there. There are two types of virtual machines are there, or you can say hypervisors, that we will discuss in later on. That is type 1 and type 2 are there. So in this guest OS, these are the different virtual machines are being created. Here operating systems assume will control the underlying the hardware of the any given systems are there. And this virtualization architecture provides this illusion through the hypervisor, or you can say VMM are there. Here this VMM is say it is a software layer which allow the multiple guest operating systems or the virtual machines to run simultaneously on a single physical host are there. Okay, so these guest OS, or you can say guest these virtual machines using the resources of the physical machines, and they emulate and work as an virtual machines, work as an individual machines are there. So this is the architecture in which we provided a hardware abstractions to these virtual machines like your guest OS are there, so that they will share the resources and provide the better optimization or better throughput in this case. So what are the benefits of the virtualizations? There are generally 4 types of benefits are there. We have an improved resource utilizations. It will increase the agility and scalability are there. It will improve the fault tolerance and enhance the security is there. So first one say improve the resource utilizations. Virtualization allow you to divide the physical server or a machine into the multiple virtual machines are there or servers are there, and each virtual machines have their own operating system and their own resources are there. So this will allow run the multiple application on the given single servers are there, in order to maximize the utilization and reduce the hardware cost are there. Okay, so if we have a standalone machines, we have to run on one applications on a standalone machines are there. Now we have to run the another applications. We have to create by the another machine or server is there in order to run it. So with the help of virtualizations in a single machine, we can create a different machines, or you can say on a single server we can create multiple servers are there, and though in that server multiple servers we can run the different applications on the given single servers are there. So they will help in order to maximize the utilizations, and also there it will reduce the hardware cost are there. Second is increase the agility and the scalability are there. In virtualizations, you can create, or you can say you can add or remove the resources immediately are there. So that this virtualization help us to scalable in terms of where we can increase or decrease the resources depending upon the requirement of the users are there. So virtualization make it easy to provision and deploy new virtual machine quickly. This allow you to quickly scale your computing resources or up or down to meet your challenging needs are there. Okay, so generally in the cloud computing, if the resources are increases for the certain interval of times, your hypervisor will see whether the resources are going up or not. If the resources are going up, after certain period of time, it automatically increase the resources for the given virtual machines are there. Same case with the if the resources are not being used and resources are provided in abundantly to that any, let's suppose X machine is there, and if hypervisors if they see that this machine is not using the resources, so they will automatically decrease the resources are there. So scalability helps in virtualization in order to better resource utilizations are there. Third one is improve the fault tolerance. If a physical machines fails here, the VM running on can be easily moved to the another servers are there in order to minimize the downtime and data loss are there. Okay, so what it means, if let's suppose one server is there and we have 2 or 3 virtual machines are running on it, and now if the server is down, we already know we can have these virtual machines a backup are there. We can automatically from the other hardware or other servers where those replications are kept can be used for the running those servers are there. Once that server which is being down, they are that server is up. Now that server will overtake and start working on it. Fourth one is it will enhance the security is there. Generally in virtualizations, these virtual machines works on the isolations. It means let's suppose there are 2 or 3 virtual machines are there. The virtual machine will not be know whether there is another virtual machines are there which is being running on the same resources are there. Okay, so in virtualizations, you can isolate the application from each others, and this help us to prevent the any malicious software to enter into your virtual machines are there, or you can say that helps them to spread within that machines are there. So these are the benefits with respect to virtualizations. That these benefits will help definitely. Nowadays, more and more companies are moving towards the virtualizations. We have the Facebook, we have the all the OTT platforms are now the moving towards the virtualizations are there, so that they can provide the better resources and better utilization, better efficiently provide the resources to the consumers are there. So virtualization plays a pivotal role in cloud computing. Here, why it is being? Because here in this case, in cloud computing, you don't need a hardware. You just create the virtual machines, and you can provide that virtual machine to the users are there, where the users buy it, or you can say they use those resources, and how many times depending upon the usage they will be charged there. So resources are here in rented as they are needed by the users on these clouds. So various in this cloud computing, the various resources can be created are there. Like user can choose their own operating systems are there. They can choose the software are there. They can choose the operating system which can run on the large servers are there. They can instantiate more virtual server or shut down the existing one within the minutes are there. So in the cloud computing, either you can use it, the predefined images are there, or you can use the, or you can say you can create your own images depending upon your requirements, and depend upon their usage. You will be built by the these cloud computing services providers are there, just like your AWS is most widely used. We have an Azure is there. We have an, Google Clouds are there. There are various models are being there where we can have these public clouds are there, private clouds are there, hybrid clouds are there, community clouds are there. So they are provide these services to the individual users as well as the companies, small base company or the big companies are there. Okay, so as I told you, the hypervisors plays an important role in virtualizations is there, where they monitor the all the resources of the provided to the virtual machines are there, and they also interact with the physical machines are there, because it seems that whatever the applications or tasks is being running on the virtual machines, they have to communicate with the actual hardwares are there, that is being managed or done by the hypervisor are there. Okay, so hypervisor is a you can say is an AK is a virtual machines manager, or you can say monitor is there, or virtualization manager is there. Is a program that allow multiple operating systems to share the single hardware host are there. So for each guest operating systems appear to have the host processor, memory, and the other resources all to itself are there. However, the hypervisor is actually controlling the host processor and the resources that is being needed by the that operating systems are there. So hypervisor, or you can say VMM, plays an important role in order to run those virtual machines. They basically control the resources, or you can say they manage the resources of the virtual machines, and they have the interactions between the guest operating system and the host operating system also are there, or they can have the interaction between the guest operating system and the hardwares are there. There are generally two types of hypervisors are there, type 1 and type 2 are there, where the type 1 hypervisors are called also called the bare metal hypervisors are there. It means they are directly running on the hardware of the systems are there. There is no operating systems are being installed. They directly create, you can create a virtual machine directly on those any given hardwares are there. Okay, so they direct in these type of hypervisors, these virtual machines interact directly with the physical machines are there. Okay, but in the case of type 2 hypervisors, we install the applications on the let's say you will create an virtual machines by using the VirtualBox or VMwares are there, where these VirtualBox or VMwares are being installed on the existing operating systems on the existing computer hardwares are there. Okay, so in this type of hypervisors, whenever they run on the multiple operating systems on a or you can say they can run the multiple machines on a single machines are there. So type 1, in which we say it's the bare metal hypervisors, where the we can directly install the virtual machines on the given hardwares are there. But in the case of type 2, given hardware is there, we have in that hardware operating systems are already being installed, that is called host operating systems, and on that host operating systems we can create multiples virtual machines are there, but with the help of an application such as your VMware, your VirtualBox, or you can say Zen VirtualBox are there. Okay, so different companies having the different nomenclature name are there, where they provide the applications to create the virtual machines for the type 2 hypervisors are there. So this is the where pictorial presentations where we have this. This is the type 1 is there, where we this is called VMM on the hardwares are there. This is the hardware. Actual machine is there, where we install the layer of the virtual machine monitors are there, and on that VMM, these we have installed. Let's suppose in this examples, 2 virtual machines are being installed there. So different types of applications are there, like we have a Zen, we have a VMware, ESX servers are there, Hyper-Vs are there. Mostly this type of operating hypervisor, or you can say type 1 hypervisor, is being used on the server sides are there. Okay, so they are operating system independent virtual machines are there. But in the case of type 2, we have here hardware is installed there, and in that hardware we have this host operating systems is being installed. In that, this VMM will help us to create different virtual machines are there. Okay, so we can have the KVM, VMware workstations, VirtualBox, different applications are there which helps them in order to install the create the virtual machines are there. They are basically dependent upon the virtual machines are there. Okay, so these are the types of 2 types of virtual machines are there, type 1 and type 2. That depends upon where the hypervisor is there, whether the hypervisor is directly installed on the hardware or it is being installed on the given operating systems are there. There are generally 2 types of virtual techniques are there: software virtualizations and hardware virtualizations are there. Full virtualization, in that for full virtualization using binary translations, and para virtualization, OS assisted virtualization, and hardware assisted are there. In the full virtualized techniques, we used to provide the virtual machines environment which is completely simulate of the underlying hardware. In this all operating systems applications which run natively on the hardware can also run on the virtual machines are there. Okay, so whatever the application that is being run on the hardware, that can also be run on the virtual machines are there. So in this, gas OS is not aware of the existence of virtual machines, and each virtual machines are independent to each other are there. So this is the full virtualization, where we perform the binary translations of the guest OS are there. Here we have 4 rings are there. Ring 0, 1, 2 and 3 are there, and during the executions of the applications, the guest operating system will be having the higher privilege, and the user application will have the least privileges are there. Once whenever these applications are running, or guest is operating system say giving the instructions, they send it to the VMM are there, and then they send it to the this VMM will send it to the host machines are there. However, we can directly send the instructions from the user applications to the host machines are there. That will have this direct sending of the instructions for the execution of will have the certain advantage and disadvantages are there. We will discuss right now. This is the para virtualizations, where we have a hardware there, host or operating systems are there, then we have a hypervisors are there. Here in this case, we have a modified operating systems are there. Okay, like in full virtualization, there is no modified operating system, but in the para virtualization, modified operating systems are there. Okay, so this is the para virtualization need to modify the guest operating systems. Here the APIs required the modification of the user applications are there. So this is the difference between the full virtualizations and the para virtualization are there. Okay, so here they user can send directly or they have to send by the VM, then request to the other. And this is for with respect to your para virtualizations are there. So in general, we cannot directly execute the request in the full virtualizations because the full virtualization require hypervisor, which is a layer of software that sit between the physical and the virtual machines are there. So they require some translations that is being done by the VMM are there. But in certain conditions, we can allow the direct interactions of the user application with the hardwares are there. So in that we can use the direct so that this direct execution can happen in the full virtualizations are there. Advantage, this will help to improve the performance, reduce the overhead and increase the flexibility is there. So by passing the hypervisor directly can execute the performance of the user request. Direct execution can reduce the amount of the overhead associated with the virtualizations. Increased flexibility, direct execution can provide the greater flexibility for the user and administrators are there. But they have the disadvantages there. Security is one of the major problem can arises in the if we have a direct interactions from the user application to directly to the your hardwares are there. So security risk is there. Complexity will also increase, and there is no limited support are there. Not all the hypervisors support the direct executions are there. So another type of hardware assisted virtualizations are there, in which we have added one more rings are there, that is ring -1 is there, where the hypervisor is there. We have a hardware hypervisor and unmodified guest operating systems that can interact with the virtual machines are there. So generally there are two types of virtualization techniques: software virtualization technique and hardware assisted virtualizations. In software, we have a full virtualization using binary translations, and the para virtualizations we have a modified operating systems are there which interact with the hardware of the with the help of the VMM are there. But in the both of cases, we can user application directly interact with the hardware, but with the certain conditions are there. Okay, so this is the binary translations. This is para virtualizations. Para virtualization is there. This is the difference between these two are there. In direct execution can happens, but not in all machines are there. Okay. So these are advantage, disadvantage of direct executions. This is the hardware assisted virtualizations. These are the certain cloud computing providers which offer the virtualization services are there. We have Amazon Web Services are there. We have Microsoft Azure is there. We have Google Cloud platforms are there. In conclusions, virtualization is a fundamental technology that plays a crucial role in cloud computing. It's enable the resources sharing, scalability, agility, fault tolerance, and security is there. As business are increasing and moving their workload to the clouds are there, the virtualizations will continue to be an essential tools for optimizing their IT resources are there. Okay, so in short, the virtualizations nowadays is booming, and they are being increasing, because the thing is, right now this virtualization helps the users not to invest on the hardwares are there. They can use these clouds platforms where they can create their own machines and start using those virtual machines. Again, they will have certain advantages in that case, and also disadvantages in this case. Thank you.